Section 3.8 is derivatives of inverse trig functions. So, if f is differentiable at every point in an interval I, and f prime of x is never 0 on that interval, then f has an inverse, and f inverse is also differentiable at every point on the interval of f of that interval. If f inverse of a equals b, the inverse function slope relationship relates the derivatives by the equation f inverse prime of a, the derivative of f of the inverse, is 1 over the derivative of the inverse function. So this is a rule that we're going to use in general. What we're going to do first, though, we'll get to that, is to do some specific inverse derivatives that you should be memorizing. So, if u is a differentiable function of x with the absolute value of u being less than 1, that's our restriction on a sine function. We use the chain rule to get the derivative of sine inverse of u is 1 over the square root of 1 minus u squared times du dx. That's our chain rule part. And again, restricting u to being less than 1. So let's look at this as a basic sine function first, and just say if this is just x, in other words, if y equals just sine inverse of x, then y prime will be 1 over the square root of 1 minus x squared. This again is something that you should memorize. Now let me show you where that comes from. So I'm going to show you some work over here. You don't have to be able to do it this way, but it's good to see it. If for some reason you forget this formula, you can get it for yourself. So the first thing I'm going to do is write this in terms of a non-inverse function. Sine inverse of x equals y means that sine of y equals x. So if the sine of y equals x, and I put that into a right triangle, so the sine of some angle y equals x, and sine is opposite over hypotenuse. So I'm going to call those x and 1. Using Pythagorean, that makes this side 1 minus x squared. So let's derivate this using our implicit. So the derivative of sine y is cos y times y prime, equals 1. Solving for y prime, 1 over cos of y. And if I look back at this diagram, the cos of y is adjacent over hypotenuse. So y prime is 1 over the square root of 1 minus x squared. So again, this is our rule. We're going to apply the chain rule if this is anything other than a simple x. So let's try one of these with the chain rule. So find, if y is sine inverse of 8x squared, find dy dx. So my u here is my 8x squared if you're doing integration by substitution. So y equals sine inverse of u, and u is 8x squared. So there's what the breakdown is. So dy dx is 1 over the square root of 1 minus our function value squared times the derivative of the chain rule, the derivative of the inside. So there's my derivative. They went ahead and squared this term to get 64x to the 4th. And there's my final derivative for s sine inverse of 8x squared. Okay, now let's look at a few others. We also want to learn tan inverse. So tan inverse of u is 1 over 1 plus u squared, using our chain rule, du dx. So again, our simple one, d dx of tan inverse of x is 1 over 1 plus x squared. Another one to memorize. And the other one you'll want to memorize is secant inverse. This one's a little bit more complicated, but again, if we just have our simple x. This would be 1 over the absolute value of x. And you notice that this is the opposite, x squared minus 1, of our sine, which was 1 minus x squared. Okay, so let's do another one with a chain rule in it. Let's do a secant. So again, I'm going to first use my basic form, which is 1 over u square root of u squared minus 1, and then do my du dx for my chain rule. So there's the breakdown of our two functions. So 1 over the absolute value of the function squared minus 1 times the derivative of this, which is just going to be 3. So there is, they went ahead and distributed. That square root sign should go all the way across. Alright, and whoops, and that's that. Really can't simplify it any further than that. Few other inverse functions using our cofunction identities. Cos of x is pi minus 2 minus sine of x. What that does when we take the derivative of cos inverse x, pi over 2 goes to 0, so we end up with negative derivative of sine inverse. So that was our sine inverse. d dx of cotan inverse x will become again the opposite of our tan inverse equation. And d dx of cosecant inverse x will be the negative of our secant function, which looks like that. So knowing that these are a shift of pi over 2 units will allow us to remember which one goes with which. Calculator conversions, write these down because these are good to know if you need to do an inverse function in your calculator. We're not going to be using that a whole lot. So let's do one more example. Find the derivative of y equals cotan inverse of x squared. So cotan is going to be the opposite of our tangent, and we're going to need a chain rule on it. So setting up our negative in front of our tan inverse, and our inside function that we're going to use our chain rule on. So dy dx, as I said, that goes away, so we just end up with negative 1 over 1 plus this squared. That's my basic cotangent derivative. And then du dx of x squared, which will give me my 2x. And that's it. Okay? So quite a few to memorize here. You need to get at least the basic 3 down: sine, tangent, and secant, and then knowing how to get the others by putting a minus sign in front.